So, analytical methods. I think I mentioned it before. The importance is enormous. As better your tool, as better your research is. And it's like in any industrial field, the tools you use are giving you a higher chance of success. And I will try to go through a couple of them. It's by no means I wanted to cover all the methods which are available. I picked up some to show you some interesting results. And if some methods are not here, does not imply they are not important. And it is just for 1 hour I still have to speak. So, and also not that I'm not using them. I just took some methods which I thought may be interesting for you. Now, I repeat slides from the first talk to remember you that you should not think your protein is stable. So many things can happen and never get to a hype and say, oh, how stable my protein is. Better be careful and think and be happy later on. I will start with HPLC page, ion exchange, capillary type of these methods, which are standard methods. We speak of protein aggregation. And this is related to another phenomenon, which is very difficult to analyze, which is binding to surfaces. When proteins can aggregate, we notice it because we are at high concentration, it starts to be turbid, we notice it. However, if you will have the challenge, develop a protein formulation at 1 microgram per ml, or develop a protein formulation at 10 nanograms per ml, then you'll have other challenges. Then you'll ask, and I will show you here, we have methods to look at aggregation at 10 nanograms per ml, which I think no laser scatter and simple methods can do it. And they are related phenomena. Molecules find themselves at high concentrations, they can find also the walls. I'll try to cover some of them also. When we look at proteins, they like water. Here is a paper from '93 on water interaction with proteins. You have regions in the proteins where water can bind, like narrow crevice and wide crevices, and also holes inside of proteins with longer time-bound water. If you totally lyophilize the protein, if you take all the water out and then you put water back, they may not come back to the same positions. So they may start to aggregate differently. So understanding the proteins, so I'm speaking now about general considerations on methods. We spoke about this also on that we need to adapt the methods to the needs of the analytical techniques. And I will give you examples on this, and I think also in the first part until now we covered this point. These are different methods. I don't repeat what I said before. This is a general question. We always want to have optimized methods. What is an optimized method to study, let's say, protein aggregation? We should be very careful when we start to think like this. For example,